All right, hello. I just wanted to do a quick video about how I do my species distribution modeling. This is part of my dissertation research for Great Basin bristlecone pine ecology and distribution. So this is going to be going through the process of getting data ready to be put into MaxEnt, maximum entropy. And then I'll show the settings that I use in MaxEnt, and I'll show you how to get the data into ArcGIS Online after it's been processed in MaxEnt. So here we go. So the first thing I'll do is create a new map in my ArcGIS Pro document. Okay. So I've already got this master. If I can find it here, a master feature class for all the different regions. So I'm doing this modeling kind of on a regional scale instead of across the entire distribution of bristlecone pine, and that seems to improve the quality and I guess how realistic the model seems to be. Okay, so I'm going to copy and paste this into my new document. I want to call this one, I'm going to be modeling the spring range, the spring mountains and the sheep range in southern Nevada. Okay, so I'm going to call this spring mountains sheep range. Okay, and then I want to copy and paste that. Overall, it's like a boundary for bristlecone pine occurrence, we'll say. Okay, so I've just been chopping out little pieces of that to basically constrain my model. Okay, so since these two ranges are rather close together, similar climatic conditions, the spring mountains have a lot higher elevation range than the sheep range does, but I think just because these are such close proximity, we can model these together and see what we end up with. Okay, so what I want to do is go to edit. I'm going to use the select tool. Just want to make sure that these are selectable. Okay, and then I'm going to hold the shift key and select both of those polygons that I've created. Okay, so these are just kind of rough sketch outlines of the range. Okay, and I probably should extend this out because there's some decent elevation along here in La Madre Mountain. So I might actually just edit that really fast and add a little bit of area around here. Okay, so I'm going to change the vertices on this and just kind of go out to here. I was looking at La Madre Mountain yesterday, and it seemed like it might be, possible. I don't have high hopes for it as far as bristlecone pine occurrence, but it's a possibility. It gets up over 8,000 feet, so it's potential maybe. Now we're getting out here kind of low elevation, so I don't think there's any possibility there, but just change our boundary about like that. Okay. And then I'm going to save my edits. Okay, so I'm going to hit select again, select that, and select this, and I want to merge those features together. Okay. So this is going to make a multi-part polygon feature, meaning that both of these are even though they're separate spatially, they're the same polygon in the attribute table. Okay, and then I want to export those features as a separate feature class. Okay. Oh, it says pending edits. I need to hit save on my edits. And so I'm going to go to, I'm trying to remember how I had this set up here. Let me just double check something here. So Hot Creek range boundary is found in a geodatabase that I've made for the Hot Creek range. Okay, so I need to change my output location to Alright, so I'm going to make a new geodatabase for the Spring Mountains. Alright, and then once I'm in there, I can just call this Spring Mountains Sheep Range Boundary. Okay. And then hit run. Alright, so now that I've got my boundary just for those two ranges, I'm going to delete the big Pilo regions polygon. Okay, so that's all I'm left with. Okay. Okay, so now we need to bring in the bristlecone pine features for just those two ranges. Okay, so what I'll do now is go to map, add data, and then I need to go to folders. Grab my latest Pilo extent data from 10 days ago. All right, so these are Charlet's polygons for the sheep range for bristlecone pine occurrence. And then this is a huge massive polygon for Mount Charleston. Got a couple other little small polygons in here. And then we have this guy down here on Potosi Mountain. Okay, so this one's a little less certain. We need to get up there and field check this one. This is based off of a report from Dana Bailey from the early 70s. He found some bristlecone growing up there, but it's not something we've been able to verify externally from that. But if anyone's an authority on bristlecone, it was Dana Bailey. So we're gonna just call that area. Even if bristlecone is not there anymore, it might have, the trees that were up there in the early 70s may have died since then, but we're going to call it suitable habitat nonetheless, okay? So that is what we're left with. So we want to, and I always cheat and I go to, previous geoprocessing tasks that I've done, and I just change the inputs and the outputs. Just to make sure that I have the settings. So I need to I need to select all of the bristlecone polygons that are within these ranges. Okay, so I'm going to go to select by location. Input is bristlecone extent. We want bristlecone extent features that intersect Spring Mountain sheep range boundary. Okay, making a new selection and click run. Okay, so that is selected those polygons that are within the stands. Okay, so the goal here is we need to get the polygon data turned into point data. And I don't want to just go do the feature to point tool because it's only going to put one point in the center of each feature. I want many points so we can kind of have equal representation of all the area within the polygons. Okay, so I'm going to use the random points tool, create random points tool to be able to do that. Okay, so the next step is to just double checking here okay, so I want to do create random points. Let's see what this is actually. Yeah, that's just never mind. Okay, so create random points. I'm just recycling what I did before. So I'm going to my Spring Mountains sheep range database as my output. My output's going to be Spring Sheep pile of points. Okay, then my constraining feature class is going to be my boundary. No, I'm sorry, it's going to be the okay, I didn't export those out. That's the step I was forgetting. Okay, so now that I have those two selected, I'm going to export them as a new layer. Okay, and I'm going to call this, I'm going to put it in that Spring Mountain Sheep Range database as well. And then I'm going to call this Spring Sheep Pilo Features. Okay, now that I've turned off that other one, everything else should be gone. Okay, so now back to my train of thought here. Now we want to create random points within those bristlecone pine polygons. Okay. No, not White Pine Range. Spring Mountains, there we go. Constraining feature class is Spring Sheep Pilo Features. Okay. I'm going to call this Spring Sheep Pilo Points. Okay, so we want 100 points per field. I mean per polygon. Okay, and we want the minimum allowable distance to be 500 meters, half a kilometer. Okay, so it's going to try to lay 100 points in each polygon. For the smaller ones, it's not going to be able to do that. It's going to give us a warning, but that's okay. And those points are going to be 500 meters apart, which seems like a reasonable sampling distance. Okay, so these points are going to end up being the samples that we'll put in as occurrence locations into MaxEnt. Okay, so it's giving us a warning. It's saying the specified number of points cannot be created in all cases due to restrictions from the minimum allowed distance. Okay, but we have a good number of randomly located points for each polygon, even the little bitty guy here. Okay. Looks pretty good. Okay, so now we need to prep the point data to be put into MaxEnt. That's our next step. Okay, so I'm going to go into the attribute table, and then I need to add some fields. Okay, MaxEnt has a very specific way that it needs the fields set up in the sample, the occurrence data. Okay, so the first field has to be called species. Okay, and it's going to be a text field, And then the next one is going to be our longitude. And it has to be called long. And then, of course, longitude is going to be a double precision floating point. And then latitude, also going to be a double. Okay, so we'll save our fields. Close that. All right, so now we can just calculate all the species. Obviously, are going to be bristlecone pine. You could have multiple species, though. That's something that maximum entropy allows. Okay, so I'm going to calculate field. I'm just going to type quote Pilo. Oops, single quote. Okay, and then longitude, going to do calculate geometry instead of calculate field. And I can actually do both in the same tool. Okay, so longitude and latitude is my target fields. Property on longitude is going to be x coordinate, and latitude is the y coordinate. Our coordinate system is just the same as this, which I'm working in WGS84 because I'm working across a really large area. And then hit run, and that will populate the coordinates for these two fields. Okay, so the next thing I need to do is get this table out of ArcGIS into a CSV file. Okay, so I'm going to export that. I'm going to put it in an actual folder called the same thing as this. So make a new folder, delete the extension. Okay, and I'm just going to call this Spreadsheet Pilo samples. And I actually need to name that .csv. Okay. All right, and you can see it put it here in the standalone tables. I'm just going to remove it from there because I want to go in and edit it, and I don't want it to be locked or something weird like that, so I just don't want to have it open in ArcGIS. Okay, so I need to find in Windows Explorer my folder that I just created, Spring Mountain Sheep Range. Okay, here's that CSV file. So MaxEnt only needs these three fields. Okay, so I can just delete these other two. And you hit delete. So there we go. Okay, so this is ready to go. I can put this straight into MaxEnt, and I've got 125 sample points here. And I hit save. Yes, I do want to keep using that format. And it does weird stuff when you try to save CSVs. It asks you like 10 times if you want to save it, if you actually want to save it, and if you want to keep it as a CSV. Okay, so I can close that. So the next step is to prepare. I've got my sample points for bristlecone pine established, and now I need to clip some environmental layers to these boundaries. Okay, so we're only doing modeling within these areas and not outside. Okay, so I have created a model, a model builder model for doing this. Okay, and it's set up as a tab here in my ArcGIS Pro document. I'm gonna kind of close all this stuff to give me a little bit more room to work. Okay, so I've got the environmental variables in a folder as TIFFs. So let me just go to that folder real quick and show you what that looks like. files, TIFF latest. Okay, so these are like this guy right here is these are amplitude, duration, max NDVI, max something else. These are all MODIS derived data sets. Okay, this is prism elevation. This is prism like precipitation, 30-year normal. This is the mean temperature, I believe. No, I think that's actually the mean dew point. The Tmax is the max temperature. Tmin is the minimum temperature. Yep, okay. And then I've got soils here. Soils is my only categorical variable. Gotta be really careful about that later on to specify soils as a categorical variable in MaxEnt. Okay. This is these are two more MODIS data sets. And this is the topographic ruggedness index. Okay. Just want to see when these were made. I think that's the latest. Okay. So those are the variables that I'm using for modeling. Okay. So this piece of our model is linked to that. Okay. It's linked to that folder that we were just looking at. It's going to iterate through all of those, and it's going to take the name from each raster, okay, and then it's going to clip each raster to the region boundary. It's going to resample it so the pixels are aligned. Okay, that's something that MaxEnt will give you warnings and fail on the processing all day long if you don't have the pixels exactly aligned. So I use the resample tool just to make sure that all the pixels are, that the cells, the raster grid cells are aligned correctly. Okay, and then we have to turn those rasters into ASCII files .asc, which is one of the acceptable inputs for raster data into MaxEnt. Okay, so before I go and I haven't actually made this into a full-blown geoprocessing tool. This is just a model builder model, and it's good enough for this. I probably could tweak it and make it better, but it's fine. Okay, so region boundary, I'm going to change that to the boundary for the Spring Mountains. Okay. And then I need to highlight this clip underscore wildcard name .tiff and put it in a different place. And that place is that Spring Mountain folder. Let me just double check my folder structure for one of these other ones. Okay, so I need to make a new folder in here. Paste that name in there. Okay, just double check that it's getting the right place. Okay, I do want to use the input features for clipping geometry. I do want to maintain the clipping extent. Okay, and this should adjust the rows and columns and resample things to match, but I found that it doesn't hurt to run through the resample tool again as well, just to make sure. Okay, so resample, gonna do the same thing here. Make a new folder, call this one resample. Hit save. I'm not going to worry about the output cell size or resampling. I'm just going to leave as nearest neighbor. Okay, and then finally the raster to ASCII. I'm going to change the output to, let me just double check this other one real fast. Okay, so this is where I put it on my desktop. Okay, and there's a couple reasons for that. One is that raster to ASCII tool does not like outputting. It can't output things to a folder where you have a space. And I keep most of my stuff in my Google Drive folder, and the problem with Google Drive is that the folder is folder name has a space in it. Okay, so there are certain tools in ArcGIS that don't like that. They'll just give you a random unspecific error. I think actually this tool does give you a specific error, but anyway, so I just make a folder on my desktop, and you can see I've done a lot of these already. And I'm just going to call this Spring Mountains Sheep Range, and then I'm going to make a folder in here called Spring Sheep ASC. And then I need to I'm just going to put the wildcard thing. Okay, name percent, and then it should make that .asc. Yep. Okay. So now I'm just going to highlight the whole thing, click validate, and that clears anything that was run previously, and then I'm going to hit run. Okay, let me open up this folder and we can watch it fill it full of files. Let's kind of minimize this down. Okay, hit run. And usually this just takes, I don't know, 3 or 4 minutes. All right, so this is finished. Sometimes it tells you it's done, and other times it just kind of freezes. And I know it's done because all the variables are present, but it doesn't tell you that it's done every time. It's just one of those little weird things that happen sometimes. Okay, so I'm going to close that. And it's probably a good idea to just glance over the variables and make sure everything looks like it's okay. I usually don't do that, but it's probably not a terrible idea. I might just pull one of them in to make sure that it looks okay. Let's let's do our prism elevation. Okay, so that looks good. All right, so we are now ready to open up MaxEnt. And there's a lot of weird things that you've got to do with MaxEnt. Okay, it's kind of picky. So I just keep the batch file for MaxEnt on my desktop. So one thing I've been getting, I've had a lot in the past, was these memory errors where it talks about, I can't remember the exact wording, but basically you can solve that by going in and just, the default is 512 megabytes of memory, and if you just add some more memory, that seems to help. Okay, so I just added 10 on here because I've got like 32 gigs of RAM on this computer. Okay, so I double click on the batch file, and then I navigate to my sample file. I'm just going to go to recent Spring Mountains. Okay, so there's my sample CSV, and it'll populate the species that it sees in that CSV folder, or CSV file, I should say. Directory file for the environmental layers. So this is where I navigate to my desktop folder that I've created. And then I go into Spring Sheep Ask. Okay, so I do want it to create the response curves. This is going to tell me, as each variable changes, how does the model respond to that. So I want that. I do want to do a jackknife to measure variable importance. So that tells you how each variable is weighted more or less relative to other variables in the model. Okay. I want my output directory to be on the desktop, so it's going to be on the same drive as the environmental variables, and then later I'll move that over to my Google Drive for permanent storage. I'm just going to call this output underscore 2020 0430. Okay, there's a couple other settings that I like to change. I do replicates, so it's going to run it 10 times and then average the results. That actually gives you minimum, maximum, and median values across those 10, as well as mean. So I usually just go with the mean. Okay, and then I want to go to advanced, and I want to write the plot data. This is going to let me pull things into R later if I want to do some plots to show variable response and things like that. It's not just going to write graphics. It's going to actually give me tables that I can use to write to create my own graphics if I wanted for publication and things. Okay, so that's the only thing I think I change in there. There's a lot of other stuff you can change that I haven't read up on. So those are the settings that I change. And then you cross your fingers really tight and you hit run. Okay, so this is common. We're missing environmental data at a certain location. And that's because some of the MODIS data kind of has like no value, no data holes in it. And so those points that fall in those holes just won't have an impact on the model, and that's okay. All right, so it's going to run through this process 10 times, and depending on the size of the area that you are doing, this could take hours and hours. My guess is that this will take a couple hours for this data set. I could be way off on that estimate. But one thing I like to do is go into the folder, the output folder, okay, and just see what it's giving me. Like double click on the HTML See, it already has done a lot of the processing, or a lot of the generating of stuff that it makes. Okay, so main thing I want is this map. This is to me the most valuable part of this whole thing. Okay, so each of the white points it's using as samples of presence data, and the purple, I believe, it's like 10% of the total number, and it's using those as checks for that jackknife thing that we selected. Okay, and the annoying thing is that on this map, the little squares that represent the sample points cover up the probability values, so you can't really see the probability values very well. Okay, so what I'll do is I'll just go back into ArcGIS and pull the ASCII file into there. Okay, and again, this is only for the first iteration. Okay, so the average, the mean model after we do 10 iterations is going to look a little bit different, but this gives us an idea that this is working okay. So let me turn off my Pilo points, and you can see if I zoom in, those holes, and those are, I believe, no data in the MODIS data, places where there was no data, where the model wasn't calculated. Okay, so my preferred symbology is going to classify. I want to do, classification method is define interval. I'm going to make the interval 0.1, and this gives me a class for each 10% of probability. Okay, then my color scheme, I like this red to white to blue. And then I go into the formatting for the color scheme, and I do a little more tweaking in here. I reverse it, so blue, basically cool colors are low probability and warm colors are high probability, which is the opposite of the default. And then I click on this bottom end down here, and I change the transparency to 100%. So that basically means that the dark blue goes away and low probability gets colorized as transparent. And then as you get up to 10%, it goes fully opaque. And so basically you're getting rid of all of your between 0 and 10% probability pixels. They're going transparent. Okay, that leaves us with that. And then the other thing that I do is go to the resampling, and I change that to cubic convolution. That gives me a really nice, smooth probability map. Okay. So La Madre Mountain did not get flagged as high probability, which I'm not terribly surprised about. Okay. One thing I have found is that you don't necessarily want to discount these areas that are really low probability. I have searched for some of them and found bristlecone even in low probability areas. So just because they're less probability doesn't mean that bristlecone might not be present there. Okay, there's Potosi. So like right in here, I'm guessing if we look, we'll see some little peaks. And so there's an 8,400 foot mountain there, and there's an 8,300 foot mountain. If we go into our base map and change it to imagery, I like to just kind of take a look at what the vegetation looks like. Okay, so yeah, it's hard to tell from the imagery, but looks like it could be some potential for bristlecone there. And the only way to really know for sure is to go out and field check it, field verify. So it looks like along this ridge is pretty somewhat likely that there would be bristlecone pine there. And let's look at our sheep range. And again, you know, those low probability areas may look totally different when we get our average model, okay? So Charlet's polygon that we're pretty sure is accurate is, there it is overlaid on top of it, okay? So it looks like there might be a couple more spots here where we could extend that polygon out a little bit. Again, we'd need to field check it, okay? So up here in the northern end of the range, there's nothing that's being flagged as above 10% probability, okay? This little guy right here is interesting. Let's look at that. Turn on the topo base map here. Okay, so there's a peak that gets up to 8,000 feet right there. So that's kind of the low end of possible bristlecone. And let's turn on an imagery layer again. Yeah, there's nothing screaming bristlecone there, but it could be, you know, a component of the mixed conifer forest in there. Be kind of interesting. This sheep range is really, really remote. It's in the Desert National Wildlife Refuge north of Las Vegas. And it looks like you'd have to hike in from this little road over here to get over to this. I don't see any roads that are closer than that. Yeah, Charlet has done quite a bit of exploring in the sheep range, but it's really, really remote and hard to get into, hard to get up in the mountains. There's no roads that go into the mountains at all. So you've got to hike in. In his recent book, he had some really cool helicopter imagery. There's some where he had gone flying in a helicopter and taken pictures. There's some nice ponderosa pines mixed with bristlecone pines along the spine of the range here in a few places. Pretty cool. All right, so that's how that works. I'm not going to wait for this to finish processing, but I do want to show how I get this data into ArcGIS Pro. Okay, so all I would do is right-click on that ASCII file. Once I get the once I get all the iterations have been run, it'll say Pilo. It'll give me a file called Pilo mean. Okay, so that'll be here instead of Pilo 0. And then I just go make sure it's symbolized correctly. Actually, I'm forgetting one step. So I want to merge that with my overall species distribution model across the entire range of the species. Okay, so to do that, I use the tool called Mosaic to New Raster. Okay, and I have this. If I go to my all ranges, all regions, I should say. I have this kind of master species distribution model raster, okay? And so I would just do that mosaic to new raster with the previous all regions with my new probability map for the range that I've just run a model for. Okay, so that's going to merge those two data sets together. And so once I've done that, I just go to right click, go to sharing, and then go to share as web layer. I name it. A web layer does not have to have underscores, so you can take out the underscores. So I would just probably write like Pilo species distribution model, all regions, and then in the summary I'd put, you know, Pilo SDM for such and such date. Okay, I date everything just so I can keep track of versions of things that I'm working on. Okay, and then tags, I just put Pilo. The Pilo is my bristlecone tag for all my bristlecone projects. Okay, you'll want this to be a tile layer, not a feature or vector tile. It needs to be tile. And then if you want to put it in a subfolder within your ArcGIS Online files, you can do that. Okay. I always just share with everybody and then hit publish, and then I'll put it on the ArcGIS Pro. Usually takes a few minutes to run. Okay, let me get to my content. Okay, so Pilo SDM all regions, that's the one that's currently in my map. So it'll show up like that here in your ArcGIS Online content. So your tile layer, if you just go in there and just double check it, should be good. And then I have this web map that is kind of my what feeds into my web app that I'll show in just a minute. So if I go to this Great Basin Bristlecone Pine distribution map, web map, and click on that, and open that in the map viewer. Being a little slow to load here. Hopefully it's not broken. Let me check my web mapping application and make sure it's still doing okay. There we go. Okay, so it looks okay. I don't know what's going on with this one. Oh, there it is. I just wasn't waiting long enough. Okay. So I've got, you can see all the layers I've got. I've got my standpoints, which at the full zoom, each stand only shows up as a point. Okay. As I zoom in, those points turn into extent polygons. And as I zoom in further, those polygons turn into extent outlines. Okay. And I've got my species distribution model here as well, and I like to leave that off usually by default, and then people, if they're interested in it, can turn it on. But the way that if you were to modify your species distribution model, you can just delete the one that's in there already. Just hit remove, and then go to add data, search for layers, and then just add in the new one that you've created, that you've uploaded. Okay. So that is the entire process from getting, taking your, obtaining point samples for MaxEnt, and also clipping the environmental variables down to size to be able to feed them into MaxEnt, and then running your species distribution model, and then putting the distribution model into ArcGIS Online to share with others. So that is the entire process. Thank you for watching.